Salam, hi everyone. I'm Azmi, first presenter from Group 5. Datasets are from kaggle.com. The first dataset is student performance, and the second dataset is student general info. The dataset are mainly about student performance and demographic or behavioral factors that could influence the examination score. So this dataset share common keys, which is student ID and suitable for integrations. From this dataset, our main objective is to identify and shortlist well-rounded students with good academic performance and active involvement in extracurricular activities for job recruitment program. Next, in data preparation stage, we focus on ensuring accuracy, consistency, and completeness before integrations. We look for structural error by removing duplicates, trimming white spaces, and standardizing text cases. For missing data, we considered three strategies: deletions, mean or median imputations, or predictive methods such as regressions or KNN. Outliers will be detected by box plot and histogram and test whether we decide to cap or remove them. Once data set were clean, we integrate them using student ID as the common key. Okay, on this section, I will explain our code used for data exploration and pre-cleaning stage. We started by importing both datasets, student performance and general info. We use command like dim, str, any duplicates, and call sum to check their structures, duplicates, and missing values. Then summary and describe give us a quick statistical overview of each variable. For visualization, we create bar plots and box plot to inspect distributions and identify outlier. In dataset 1, numeric columns, we find anomalies data such as age is 2, 3, and up to 120 years. There are also sleep hours more than 24 hours and etc. Several character columns do have inconsistent entries. The date format also need to be standardized. Then the same process apply to dataset 2.
My name is Anna Amri. Today I'll present part 3 data cleaning for both datasets, student performance and student general information. For dataset 1, as explained earlier by my teammate, we imported it using read.csv, remove extra white spaces, handle text as missing values, and display the first 6 rows using head. Using str and summary, we identified initial issues. Each column was not numeric, that register was a character, gender and part-time job had inconsistent text. To fix this, we clean the data with tidyverse. For age, we remove symbols converted to numeric. For gender and part-time job, we standardize them to lowercase and corrected inconsistent entries. For date register, we use LubriDate to parse and convert multiple date format into date type. Next, we remove 6 duplicate rows, leaving 1000 clean observations. For missing value in study hours per day, we applied 2 methods. First method, median imputation. We replace missing values with the median and visualize before and after histogram. The distribution remains stable. This method was chosen because the data was skewed to the right, so mean imputation was more suitable than the mean since the median is less affected by outliers and better represents typical study behavior. Second method, row deletion. We removed 20 missing rows, which reduced dataset to 980. The distribution remains similar. This method can also be used since it's only 2%. Removing them wouldn't significantly impact our analysis. Then we save the clean dataset with median imputation. For dataset 2, similar cleaning steps were applied. We standardized age, gender, mental health rating, parental education, and extracurricular participation. We also removed an empty column and 6 duplicate rows, leaving 1000 records. Missing values appeared in several variables. However, we'll focus on 2 variables, which is social media hours and extracurricular participation, since they had the most missing data and are important for our analysis, especially for understanding the student habits and job employability. First method for social media hours, we fill missing values using KNN imputation k equals to 5. KNN will preserve relationships between variables by imputing missing values based on the most similar records in the data set. This maintains the natural patterns in the data rather than replacing a single summary statistic. Second method, for extracurricular participation, we replace missing values with mode since it's categorical. Method like mean or median imputation is not applicable. Using the mode is simple and statistically efficient as it retains all 1000 records without losing data. After standardizing format, fixing data types, removing duplicates and imputing missing values, we save clean dataset 2, ready for next stage, outlier handling. That's all from me. Thank you very much.
Yes, I'm here and today I'm going to present on the outlier, specifically for dataset 2. So firstly, what we did, need to find out in dataset 2, which are the columns are numeric. So for this, we found actually 5 columns that is suitable for outlier analysis. I'm gonna straight ahead go with the outlier for column number 1, which is the social media errors. For this part, I'm using z-score, specifically because z-score is ideal for continuous data, and I start off with actually visualize the behavior of data before we handling the outliers. I standardize it first, convert it to numeric vector, and then I use 3 as the threshold. So we found out we have 3 outliers, and we are using median to actually replace the outliers. And then after the treatment, we can find the behavior of the data. You can see from here, we have 3 students with extreme outliers, 24, 30, 50 hours, which does not make sense because daily you only have 24 hours. So this is heavily skewed as well. You can see it stretch up to 50 hours. So once we fix the outliers with z-score median, so we can find that it behaves better, but we still have several outliers, but this is called mild outliers, but this is acceptable considering that some students may actually spend a little bit more time from the others on social media. It's the same. You can find that actually 5 students actually spend time on Netflix from 24 to 50 hours. So you can say it stretched out to 50. And so for this one, I input the median into the outliers for the z-score, and you can find it more acceptable, and it actually shows the real world picture. Let's proceed with the next code, which is the exercise frequency. So for this exercise frequency, I'm using domain knowledge capping because we are talking about exercise frequency in a week. So I limited lower boundary to 0, which means that student does not exercise at all, to 7 times, which is the upper bound. So this is realistic because in a week, the maximum that we can do is 7. We have 40, 30, 30, and 30 outliers. After changing it to the realistic lower and upper bound, we can see it's basically better, and we can see that at most what they can do is actually 7 times in a week. And then I'm going to proceed with the last column that we'll be discussing, which is mental health rating. So I did the visualization first, and I found out that there's no outlier detected. So it's actually within 1 to 10 scales. So for this part, there are no treatment on the outliers needed.
Hi everyone, from here on, I will continue explaining about the outliers in our dataset. Let's start with the outliers in dataset 1. Our dataset basically has 10 columns and we will go through one by one. Student ID are unique and sequential ranging from S1000 to S1999. Any duplicates were removed earlier. For each column, we use box plot and histogram for visualization and apply for z-score method to detect the outliers. To calculate the z-score, we consider values more than 3 standard deviation from the mean as outliers. In this dataset, the outliers identified were 2, 300, 20, and 150. These outliers were then replaced with the mean calculated without the outliers. To confirm the cleaning, we re-examine the data using box plot and histogram and observe there are no further outliers remain. If we run bar plot on gender column, we can see that only 2 distinct categories there, which is female and male, so no further word is needed. By running the box plot and histogram, visually we can see that there are outliers in study hours. We then identify the outliers using box plot stats. Since studying more than 20 hours per day is unrealistic, we replace the outliers with value more than 20 with the mean excluding outliers. By replacing the outliers, new box plot and histogram will look like this. Notice that there are still outliers but those outliers are acceptable and can be used for further analysis. Again, we use box plot and histogram to visually inspect for any outliers in attendance percentage column. We notice that there are 3 outliers, but as those values are within acceptable range, we will just accept the outliers. Part-time job shows 2 distinct categories after we run the bar plot and unique function, so no further work needed. Using box plot and histogram and IQR method, we can identify and visualize outliers in sleep hours column. To deal with it, we choose to impute them with KNN method. This is the result of the imputation. Using the unique function, we found that this column, which is internet quality, contains 3 distinct categories, so no further action needed. The outliers in exam score also shows that it lies within the acceptable range, hence we accept the outliers in the exam score. Code register column contains unique value, so it remains unchanged. To detect outliers in the date register column, we use the IQR method. Before performing the analysis, we first check the date format. Since the column was in character format, we convert it to date format and then to numeric, as the IQR method requires numeric value. The result shows no outliers in the date register column. Please see the before and after data cleaning for the outliers. Each column, this is before and after, study hours per day column, attendance percentage, sleep hours, exam score. And that's it. Thank you.
My name is Shukri, and now I walk through my data integration process using 2 clean data sets, using tools in RStudio, DPLYR, and Tidyverse package with 3 key fields, which is student ID, age, and gender. On the left side is student demographic details named as dataset 1, which contain of 1000 observation of 14 variables, and on the right side is academic and participation data named as dataset 2, which contain of 1000 observation of 10 variables. For data integration, I perform left join using DPLYR package by joining all 3 columns, student ID, age, and gender. The reason why I choose method of left join is because dataset 1 is primary dataset contain master list of students, meaning every student in dataset 1 remains in the final integrated dataset, even there is no corresponding record in dataset 2. This approach preserves every student from dataset 1 while adding relevant fields from dataset 2. After integration, I validate the result by checking the percentage of matched and unmatched record. The outcomes show 99.6% successful match and 0.4% unmatched. This mismatch were due to missing IDs or small inconsistency in age or gender fields. Overall, 99.6% match rate is considered strong and acceptable. The structure of dataset before join is 1000 observation of 14 variables for dataset 1 and 1000 observation of 10 variables for dataset 2. And after completed integration process, the joined dataset contain of 1000 observation of 21 variables. This joined dataset saved in CSL file and ready for analysis to fulfill the objective. Next, using Tidyverse package to sort or filter students that have good result, which is more than 97% score and participated in extracurricular activities. Result shows that 23 students were identified as well-rounded students and proceed for the job recruitment program. In summary, for key achievement, successful integration with high match rate, which is 96%, achieve strong data consistency between 2 independent datasets. Number 2, clean and structural work in flow, implemented a clear end-to-end pipeline from cleaning, outlier treatment, integration, validation, and so on. 4 challenges, handling non-perfect matches, which is 4% unmatched, encounter missing on or inconsistent student IDs and slight mismatch in age or gender. Number 2, balance cleanliness and completeness, which is cleaning too aggressive risk data loss while keeping too much introduced noise. So with that, that's all my presentation on data integration and summary. Thank you for your attention.